Angles, Part 2. Vertical, supplementary, and complementary angles. We covered some basics about angles in Part 1 of our video. In Part 2, we look at how to compute the values of the angles based on certain properties of the angles. Let's start with vertically opposite angles. Vertically opposite angles. We have seen all non-parallel lines intersect each other. When two lines intersect, they form four angles as shown in the figure marked 1, 2, 3, and 4. Here, two sets of angles are opposite each other. In the figure, angle 1 is opposite to angle 3 and angle 2 is opposite to angle 4. These pairs of angles 1 and 3 as well as 2 and 4 are called vertically opposite angles or simply vertical angles. Vertical angles are equal in value. We can easily prove that the value of the vertical angles have to be the same. Let's look at the same figure with the lines named as line 1 and line 2. We know the sum of all angles on one side of a line is 180 degrees. On one side of line 1, we find angles 2 and 3. So angles 2 and 3 are a linear pair. Let's say angle 2 equals 80 degrees, then angle 3 equals 180 minus 80, which equals 100 degrees. On one side of line 2, we find angles 3 and 4. We just calculated angle 3 as 100 degrees. Since angles 3 and 4 are a linear pair, angle 4 equals 180 minus 100, which equals 80 degrees. So we find angle 2 equals angle 4. We can also derive angle 1 equals angle 3 in a similar manner. Let's do an exercise. Two lines, line 1 and line 2, intersect as shown here. Compute the other values of the vertical angles and fill the table where one of the angles is given. Angle 1, angle 2, angle 3, and angle 4. In the first row, the given angle is angle 1, which is 85 degrees. Since angle 1 and angle 2 are linear pairs, angle 2 is 180 minus 85, which equals 95 degrees. Since angle 3 is vertically opposite to angle 1, they will be equal, and so angle 3 is 85 degrees too. Lastly, angle 4 is vertically opposite angle to angle 2 and will be 95 degrees. In the second row, the given angle is angle 3, which is 65 degrees. So vertical angle, angle 1 is also 65 degrees. Linear pair angle, namely angle 4, will be 180 minus 65, which is 115 degrees. Angle 2 is vertical angle to angle 4 and is 115 degrees. In the third row, angle 4 is given as 110 degrees. So vertical angle, angle 2, is also 110 degrees. Angle 3 will be 180 minus 110, which is 70 degrees. And angle 1, which is vertically opposite to angle 3, will also be the same. Angles at a point. We just covered two intersecting lines and each line has a linear pair whose angles sum up to 180 degrees. Here, for line 1, we consider angle 2 and angle 3 are linear pairs, then angle 2 plus angle 3 equals 180 degrees. Similarly, for line 1, angle 1 and angle 4 are linear pairs, and angle 1 plus angle 4 equals 180 degrees. So the sum of the two linear pairs will be 2 times 180, which equals 360. We know there is a specific point which the lines intersect. In our figure, we name the point as P. Sum of all the angles around point P is 360 degrees. In fact, sum of all the angles around any point is always 360 degrees. Take a look at the figure below. Four rays OA, OB, OC, and OD emanate from the point O. The sum of all the angles around the vector of point O equals 360 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360 degrees. Let's do an example. Compute the value of angle X given the other angles in the figure. Sum of all angles around point O equals 360 degrees. 122 plus 63 plus X plus 78 equals 360. 263 plus X equals 360. Subtracting 263 on both sides, 263 plus X minus 263 equals 360 minus 263. So X equals 97 degrees. Let's look at another example. Compute the missing angles in the figure. We know the sum of angles around P equals 360 degrees. So angle APB plus angle BPC plus angle CPD plus angle DPE plus angle EPA equals 360. Substituting the values given, x plus 122 plus 2x plus 46 plus 72 equals 360. 3x plus 240 equals 360. Subtracting 240 on both sides, 3x plus 240 minus 240 equals 360 minus 240. 3x equals 120. Dividing both sides by 3, 3x over 3 equals 120 over 3. Simplifying, we get x equals 40 degrees. So angle APB equals x equals 40 degrees. Angle CPD equals 2x equals 2 times 40, which equals 80 degrees. Let's look at another set of angles called supplementary angles. Supplementary angles. If the sum of two angles is 180 degrees, they are called supplementary angles. So linear pair angles are supplementary angles. Conversely, we can derive if the sum of any two angles is 180 degrees, then the angles lie on a straight line. This is very important to remember because this will come in handy whether the two angles form a straight line or not. In the figure, we see angle 1 and angle 2. If angle 1 plus angle 2 equals 180 degrees, then they are called supplementary angles. So if angle 1 equals 125 degrees and angle 2 equals 55 degrees, the sum of angle 1 plus angle 2 equals 125 plus 55, which equals 180 degrees. Conversely, if we know two angles are supplementary angles and one angle is given, then the other angle can be computed. Complementary angles. If the sum of any two angles is 90 degrees or right angle, they are called complementary angles. In the figure, we see angle 1 and angle 2. If angle 1 plus angle 2 equals 90 degrees, then they are called complementary angles. Let's say angle 1 is 42 degrees and angle 2 is 48 degrees. The sum of angle 1 plus angle 2 equals 42 plus 48, which equals 90 degrees, which make them complementary angles. Conversely, if we know two angles are complementary angle and one angle is given, then the other angle can be computed. In the next video of angles, we'll see interior angles of a polygon, transversal on parallel lines, and related areas. That's all we have on this video. Thanks for watching.